Hello everyone, I'm honored to share my paper here. My paper is titled MJR, Multi-Head-Driven Reasoning on Language Models for Question Answering. Next, I will share according to the following content. Question answering is a challenging task requiring system to comprehend and reason accurately. Pre-trained language models have shown remarkable progress, acquire language knowledge and contextual understanding through massive text vocabulary. However, their performance in instructed reasoning remains limited. Knowledge graphs like Wikidata and ConceptNet offer a structured background knowledge that can augment PRM's reasoning ability. Cages express capture external knowledge using triples, facility reasoning tasks like negation. The integration of textual data and cages have emerged as a critical reasoning focus. Traditional metaphors fuse text and cages in a shallow, non-interactive manner, limiting their reasoning capability. Encoding separately and combining at the output stage, or using one modality and complement the other does not fully explore their potential. Our research aims to overcome this limitation and explore more complex fusion techniques that can augment the strength of both textual data and cages. By enabling dynamic interactions and mutual reinforcement between the two modalities, we strive to develop question answering system with enhanced reasoning ability. The multi-level fusion model operates at a fundamental level by augmenting the complementary strengths for multi-layer representation from both a PRM and a task-specific encoder. The first key space lies in its ability to project features from selected layers of the PRM into a unified space, facilitated by the projection layer. This projection ensures that features from disparate layers can be meaningfully combined using the GELU linear structure for nonlinear transformation, which aids in capturing complex interaction between features. The formula for the fusion process encapsulates the essence of dynamic weighting and integration. Here, each selected layer from the PRM's representation is given an important weight, while the output layer also contributes with its own weight. The weighted summation not only aggregates information across layers, but also allowed the model to dynamically adjust the relative importance of different layers during training, based on their relevance to the task at hand. The joint reasoning model represents an integration point in the process of understanding and analyzing multi-modal data. By using the multiple attention heads, it combines the complementary strengths of both the LM and the subgraph encoder representations. Each attention head serves as a filter, capturing different aspects of the future representation, resulting in a more comprehensive LM representation. The process begins with the concatenation of individual attention head output. The use of linear weight mixture allows the model to dynamically adjust its focus and emphasis based on the input data. Embedding is to capture pattern and relationship that would otherwise be missed. Within each attention head, the computations of required key and value vector incorporates both the LM representation and the future representation. This blending of information enhances the model's ability to reason about complex interaction and dependence with the data. The generation function adds another layer of flexibility, transforming the raw input into more discriminated representation that facilitate effective attention mechanics. Finally, the update LM representation is filled with the graph representations to form the unified knowledge-informed view with the input data. The use of mean pooling for the LM representation and attention-based pooling for the graph representation ensure that the most relevant information is emphasized. The result probability compute through a MLP and softmax normalization provides the likelihood of a correct answer. And a comprehensive experimental evaluation conducted across 3 datasets, namely Common Sense QA, Open Book QA, Med QA. Common Sense QA is a QA dataset challenging models to reason with everyday common sense knowledge. Open Book QA evaluates specific reasoning ability with elementary fact across discriminant lines. Med QA tests the comprehension and application of biomedical and clinical knowledge for medical QA. The MJR model has demonstrated exceptional performance across various domains. In Common QA, it surpassed 5 turn LMs and FITS, providing its proficiency in common sense reasoning. It achieved notable accuracy gains, highlighting its ability in scientific reasoning. And in MedQA, MJR outperformed competition, showing case its adaptability to the medical field. Across benchmark, MJR consistently integrate knowledge graph and LMS enhance joint reasoning. Its versatility and performance set a new standard for knowledge enhanced language models, demonstrating its potential for future advances. In summary, this paper presents a groundbreaking model MJR that revolutionized the fusion of semantic information from language models and knowledge graph for joint reasoning tasks. The key innovation of MJR lies in its innovative multi-level dynamic fusion approach, which seamlessly integrates the hidden layer representation of LM with the representation generated by graph neural network opening or KG. This fusion strategy enable MJR to capture the rich contextual information from LM and the structural knowledge from KG, furthering a deeper understanding of the input. Furthermore, MJR introduced a multi-head attention mechanism for joint reasoning, leveraging the view's information to perform multi-perspective update the LM representation. These mechanisms allow MJR to read over the input from diverse angles, enhancing its ability to handle complex reasoning tasks. The extensive experiment conducted on 3 data sets, including those involving negation, double negation, and other intricate reasoning scenarios, showcase the remarkable performance of MJR. It consistently outperforms existing language model and language models plus knowledge graph, and even large language models demonstrate its superiority in tackling complex reasoning challenges. Thank you for your listening.